Hello, welcome back to my channel. In this video, we'll discuss about E1CB mechanism, that is elimination unimolecular conjugate base. From kinetic point of view, E1CB cannot be distinguished from elimination bimolecular, that is E2 reaction. Both E2 and E1CB follow second order kinetics. But it is known as E1CB because the reaction proceeds through a conjugate base. As the reaction proceeds through a conjugate base, it is known as E1CB. It depends upon the conjugate base. For E1CB, there must be two carbon atoms. Alpha position should be connected to a bad leaving group, and beta position should be connected to an electron withdrawing group. One H atom should be there at beta position. That H is acidic. At slightly higher temperature or in presence of a strong base like alkoxide ion, you can take ethoxide C2H5O minus. The acidic hydrogen at beta position can be removed. When the acidic hydrogen is removed, that carbon gains negative charge. That is the conjugate base. This conjugate base undergoes elimination to give an alkene. The minus charge on beta carbon forms a pi bond with the alpha carbon, and the existing C poor leaving group bond will break, and the leaving group leaves the alpha carbon and becomes a negative charge ion. Let us take an example. C carbon alpha carbon is connected to a poor leaving group, let it be F, and the beta position is connected to a phenyl group, and rest bonds are filled with hydrogen atoms. So there is beta carbon and beta hydrogen atoms. There are two beta hydrogen atoms. In presence of ethoxide, the beta hydrogen atom is removed. A negative charge is formed on the beta carbon, and the negative charge on beta carbon is supposed to form a double bond with the alpha carbon, and F group leaves as F minus. Now you got an alkene. This is due to elimination. This alkene is from the conjugate base. As the reaction proceeds through conjugate base, it is unimolecular elimination conjugate base, or elimination unimolecular conjugate base. This is the rate determining step. Let us apply this mechanism to another example. You see, there are two carbon atoms. The alpha carbon is connected to 3 fluorine atoms. The beta carbon is connected to 2 chlorine atoms, and one beta hydrogen atom is there. In presence of ethoxide, the acidic hydrogen of beta carbon is removed as H plus, and a negative charge is created on that beta carbon. In the next step, the conjugate base forms a pi bond with the alpha carbon. So the product is written on the screen, CCl2 double bond CF2. This reaction also undergoes E1CB mechanism. This reaction shows E1CB mechanism. You see, in the formation of benzene, you take fluorobenzene in presence of a strong base. The H atom from beta position is removed and negative charge is created. Negative charge will form a bond, and the fluorine atom will be removed as F minus, and a benzene is formed. So formation of benzene from fluorobenzene also follows E1CB mechanism. You know when acetaldehyde is treated with dilute NaOH, an aldol is produced as shown. You see, when acetaldehyde is treated with dilute NaOH, an aldol is produced. In presence of base, this H can be removed and a negative charge is developed on that carbon. That carbon forms a double bond and the OH group leaves. Now the alpha beta unsaturated aldehyde so formed is stable due to resonance. So this reaction follows E1CB mechanism. You know, when acetone is treated with hydrogen cyanide in presence of alkali, or you can say base, acetone cyanohydrin is produced. But the reaction is reversible, you see. In the forward direction, you got acetone cyanohydrin. In the backward direction, in presence of OH minus, it gives back the acetone. You see, CH3CO CH3 plus SCN in presence of OH minus gives acetone cyanohydrin. In presence of OH minus, again, H of OH group leaves the cyanohydrin group and O minus becomes minus. O minus will form a double bond with carbon and the poor leaving group Cn minus leaves, so you'll get back the acetone again. So this is a reversible process. Let us revise quickly. E1CB follows second order kinetics. R is equal to K, concentration of alkyl halide to the power 1, concentration of ethoxide ETO minus to the power 1. The reaction proceeds through a conjugate base. Elimination of leaving group from conjugate base is the rate determining step. As the reaction proceeds through conjugate base, the reaction is known as E1CB, elimination unimolecular conjugate base. The reaction proceeds in presence of a strong base at elevated temperature, and the alkyl halide should contain a poor leaving group at alpha position and an electron withdrawing group at beta position. It may be a phenyl group. The carbanion is stable because of resonance or electron withdrawing nature of electron withdrawing groups. It is a rare process. It occurs when the carbanion formed due to a strong base is stable. Let us discuss elimination unimolecular reaction, E1 reaction. In E1 reaction, a poor base will be taken and the reaction is carried out at a high temperature. The alkyl halide should have two carbon atoms. When heated at a high temperature, the CX bond breaks. A carbocation is formed. To stabilize that carbocation, it should be connected to alkyl groups, so the carbocation is stable due to hyperconjugation. Then elimination occurs and you are getting an alkene. It follows two steps. In the first step, the CX bond breaks to form a carbocation. In the second step, the carbocation loses a hydrogen atom from beta carbon and a double bond is formed. This is known as elimination unimolecular reaction. Let us compare SN1 with E1. E1 occurs at high temperature. So first the CX bond breaks and a carbocation is formed which is stable due to hyperconjugation. Then the carbocation is converted to an alkene by releasing a hydrogen atom from the beta position and a double bond is formed, and the C plus gets neutralized by the electron pair given by CH bond. So a double bond is formed and alkene is produced. But in case of SN1, what happens? The temperature is low. In presence of water, the base becomes a nucleophile. First, the CBr bond get protonated from protic solvent. The bond breaks, a carbocation is formed that is stable due to hyperconjugation. Then the nucleophile, previously in E1 it was a base, now it is a nucleophile, prefers to attack the carbocation either from left or right. So two types of products will be produced, inverted or a product with retention of configuration. So the products are optically inactive because it is a resin if the alkyl halide have a chiral center. Thank you for watching the video till the end.